Nvidia 4000 graphics cards are coming out, and if you work with Unreal Engine, you may ask, do I really need it? Or better say, just how much benefit is in there if I get one? Unfortunately, simple gaming benchmarks and specifications on the paper are not enough to answer these kinds of questions. So I made some tests inside Unreal Editor to show you how much performance improvement we get when we switch from one generation of Nvidia card to the other. And let me tell you something, if you already have seen these kinds of benchmarks for gaming, you will be surprised, because doing Unreal tasks is so different. Many of you want to buy the new cards as soon as possible, and many others just want to skip this generation at all. If you are any of these two, you should probably watch this video till the end, because depends on your current graphics card and what you do in Unreal Engine, I might change your mind. Right now there is no 4000 GPUs in the market to test it, but fortunately I have a 980 Ti, 1080 Ti, 2080 Ti and 3080 Ti, and by comparing these four flagships from 4 different generations, we can just estimate how much improvement we will have by going further than this and buying a 4000 GPU. Now let me tell you about the tests. The first test is for level designers, in which I have 2 4K displays turned on, one for the viewport and the other for extra windows like the outliner, content browser, details, etc. The second test will be about VR. VR projects are so power hungry, and this test can be helpful for VR developers. The third test is the movie render queue. I will go into details when we get there. The last test is very important for many game developers around the world, and it is baking lightmaps. I will use GPU lightmaps to bake the exact same scene with all of these cards, except this one, because the GPU lightmaps doesn't support 980 Ti. And because of this, I will do 2 extra things here. The first one is that I will bake the exact same scene using a CPU which in this case is Ryzen 9 5900X, which is so popular among the content creators and game developers, to show you the quality and time difference between a GPU and a CPU. The other thing I want to do is a little bonus here, and I know you are here for Unreal Engine and you can skip this part if you want, but for many of you this may be interesting, because not only Unity supports all these cards for GPU light mapping, but also it gives you the exact number of rays calculated per second. Before going to the tests, the last thing I want to say that is I have a couple of AMD GPUs in my inventory, so if you want a direct comparison between Nvidia and AMD GPUs, I can make that video, but it takes a lot of time to make such videos, so do me a favor and leave a comment about it so I will know that there are enough viewers when I make them. For the first test, I chose the city sample demo from the marketplace, which is free, and I opened up the small city level. You can see the frame rate here and here, and only this part of the world is loaded. In this test, what I'm gonna do is to move around the city, add some objects, move them, delete them, add lights, change the setting of the lights, and do all these things for 5 minutes and see the average frame rate. And I will try to do the exact same thing each time. The first time I go in the lit mode, and the second time I go in the unlit mode. The third time I set the screen percentage to 50, and the fourth time I will set the DLSS to performance. And this means 5 minutes of benchmarking for each GPU, except for the 1080 Ti and 980 Ti, which are GTX cards and don't support DLSS. So we will have 14 different numbers to compare. I do not record the screen while I'm benchmarking to not interrupt the frame rate. Okay, these are the numbers for the average frame rate for each test. Lit 100%, which means that it is the lit mode and the screen percentage is at 100%. This is lit and screen percentage at 50. This is lit with DLSS at performance mode, and unlit mode at 100% screen percentage. DLSS is not supported by 980 Ti and 1080 Ti. And as you can see, in the 2080 Ti and 3080 Ti, we don't see much difference. I don't know what has happened in this test, but in other situations you may see much more difference. I already have another video about this. I put it up here so you can check that if you want. Now let's talk about the frame rates. First, I want to talk about the 1080p frame rate, which means that lit at 50%, because the displays I used are 4K and the 50% means 1080p. As you can see, the difference from a 980 Ti to the 1080 Ti is a lot. But when we move to the next generation, it became less and less. So if you have a 1080p monitor and you do work on these kinds of projects, you do not need to get the next generation GPUs. Moving to the 4K resolution. As you can see, the frame rate is 8.5 on the 980 Ti, 19 for the 1080 Ti, 28 for the 2080 Ti, and 45 for the 380 Ti. Because Nvidia is focusing on 4K resolutions in the later generations. And if we imagine that this will continue like that, we probably have something like this for the next generation. When we are talking about the unlit, we can see a good improvement here, a very amazing improvement from GTX to RTX, and again less improvement for the other one. I think this is because the scene is so expensive for other parts of the system to render, and I believe that this is bottlenecked by other things like the CPU, for example. For our VR test, I found this beautiful environment in the marketplace, and the link is in the description. One funny thing about the 980 Ti is that it loads all the textures properly in the editor, but when I hit the play in VR mode, none of the textures are loaded correctly. And this tells us that for working on VR projects, you need more than 6 GB of VRAM. The next video is all about VR projects, so don't forget to subscribe if you are interested. By looking at the frame rates here, you can see that by moving from a 980 Ti to the 1080 Ti, we have around 33% of improvement. And by going to the next GPU, we have only 10% improvements and only 2% for the next one. And I don't think this is related to the GPUs. I think this is related to Unreal Engine, because I tested the same thing in other game engines and I've seen a lot of improvements when we use a more powerful GPU. Unfortunately, at this moment, Unreal Engine 5 has lots of problems with VR. And I know they are working on it. So rather than buying a new GPU, you should probably wait for the next versions of the engine. For the movie render queue test, I wanted to export my frames as PNG, and the anti-aliasing for spatial and temporal are 2 and 8, and the anti-aliasing method is none. And the output resolution will be 1920 by 1080. I will do the same thing but with the anti-aliasing at its default values. As you can see, we have tens of thousands of objects, lots of effects, complex materials, and many more things here. On the 980 Ti, we can see that the textures are not loaded properly, and we have this error here. Video memory has been exhausted. Expect extremely poor performance. The frame rate is 40 and the screen percentage is not helping at all. After rendering the sequence, I found out the final render, even with the 980 Ti, is completely okay and there is no difference between this card and others. And all textures are completely fine in the final render. And the problem with the textures is only related to the editor itself. In this chart you can see the times each GPU took to render our sequencer, which consists of around 2000 frames in the default AA settings. And the 980 Ti took 4 minutes to render it, and the 1080 Ti took only 71 seconds, 2080 Ti 64 seconds, and the 3080 Ti 64 seconds. And this shows that the GPU is not limiting us in this scenario, and if you buy a 4090 you will still get the exact 64 seconds to render this sequencer. For the custom AA, which I showed you around 2 minutes ago, we have the 980 Ti with the timing of more than 35 minutes, 1080 Ti 13 minutes and 13 seconds. The 2080 Ti rendered the sequencer at 10 minutes and 38 seconds, and the 3080 Ti took 9 minutes and 14 seconds to render the whole thing. As you can see, anything like the 980 Ti is not suitable for these kinds of tasks in Unreal Engine. If you have a 1080 Ti, it still holds. If you have a 2080 or something like that, which is so much like this one in terms of performance, it's still good. But if you move to newer generations, you can see around 2 minutes and 1 minute improvement, and maybe if we go to the next generation, we see even less than 1 minute improvement. If you work on projects with less or equal details to the project I've tested here, I cannot recommend buying a new GPU because that is not what you need. You are not bottlenecked by the GPU here. This is what we have for the Lightmap test. Everything is static here. This is the Lightmap setting and nothing special about it. Just want to show you the numbers. The lighting quality is set to production. We have a directional light, a skylight, and you can see the result of the CPU light mass. As you can see, we have nice shadows here and nice AO. We have another room here and there is no light in it. This room is only lit by emissive materials, and in order to make it work, you should change this flag to true. Use emissive for static lighting. This is for the CPU light mass. For the GPU light mass, you don't need to do this. And you can see that the shadows are not so good with the CPU light mass. I have a few rect lights here with different settings, colors, and temperatures. You can see how nice the shadows are baked. This is so beautiful, I think. And if I move any of these objects, it changes to real time and everything is ruined. The last room here, we have a very strong spotlight here with the indirect lighting intensity of 6. Let me hide this wall to show you what is inside. Okay, 3 things are happening here. The first is that the rays of the spotlight are coming and hitting this surface and going upward. The next thing is hitting this part of this box and make this wall brighter. And the last thing is that the rays are hitting the ground and make this part brighten. We have a nice AO around the corners here. Now I want to show you the GPU light mass result here, so you can compare the quality and see the problems of the GPU light mass. Okay, this is the result of the GPU light mass, which is so much darker. But the same things is happening as before, but it is so much darker. As you can see, nothing is visible here and the intensity is not taking into account as we expected. But here, as you can see, the shadows are so much softer and better. The quality of shadows is so much better in this mode. Again, here we have these nice shadows, but we have some artifacts which has been solved in the newer versions of the engine. I only used Unreal Engine 4 because in Unreal Engine 5 I had some problems baking with the 1080 Ti. As you can see, these parts are as beautiful as before and the difference is so minimal. I believe that in this version the indirect lighting intensity is not supported by the GPU light mass, and as a result we have a darker room here. For the CPU, when you hit build lighting only, you can see that some message is coming up, and after a few seconds it starts building lighting, and you can see the percentage. For the GPU, it is quite the opposite. When you hit the bake button, you can see that it immediately starts building lighting, and after it is finished, you can see the encode texturing message. In this part, I will give you two timings for each device. One is for building lighting only, and the other one is for the whole process, which means from the time you press bake button until everything is finished and you can see the result in the viewport. Orange is for the whole process and blue is for the baking time. The first thing to mention is that the difference for the CPU is only 4 seconds. But for the GPUs, for all of them, it is exactly 17 seconds. Which means that the encoding part is not related to the GPU. And I won't take it into consideration. So, we can see that the CPU took around 2 minutes and 30 seconds to finish the baking. When we move to our first GPU, which is the 1080 Ti, we can see that this time reduces to 73 seconds. And by moving to the first RTX card here, which is 2080 Ti, we can see a lot of difference. In this case, it is 20 seconds, and for the 3080 Ti, it is only 17 seconds, which is so good. So if you already have a GTX graphics card, the first thing I recommend here is to migrate to an RTX card. And if you think that 40 series cards are expensive, you can probably stick to high-end 30 series cards. I actually cannot recommend a 3050 or a 2060 over a 1080 Ti or a 1080. If you have a high-end GTX card, your next graphics card should probably be a high-end RTX card to see the real difference. Okay, moving to Unity. This is a work in progress environment without the Lightmap, and this is the same environment with the Lightmap. This location includes hundreds of objects and dozens of lights. I baked this level using all 4 GPUs with the exact same settings. By looking at the highlighted part, you can see the bake performance and total bake time for each GPU. If we consider the 980 Ti performance as 100%, then by moving to the 1080 Ti, we have a 58% uplift in performance. Again, by considering the 1080 Ti as 100%, then 2080 Ti is 52% better. And again, the 3080 Ti is 76% better than the 2080 Ti. I won't go into more details here because this video is not about Unity, but the numbers speak for themselves. Don't forget to hit the like button if you liked this video, and if you have any suggestions, the comment section is for you. I will read and respond to every single one of them. Thank you for being with me.